QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's consider this given quadratic trinomial. Is this factorable? Yes or no? Time is up. The answer is yes. If this is factorable, then what are the factors? The factors are x minus 2 and x minus 2, or the square of x minus 2. And with this, what are the roots of this given equation? We only have one root, and that's 2. Did you get 3 over 3? If not, please continue viewing this video. In one of our answers earlier, we only have one root. We expect here to have 2 roots. So let me try to explain it and the process of getting that said root. This is an example of a quadratic trinomial, but more specifically a complete quadratic trinomial, because we have a, b, and c coefficients here, and they are 1, -4, and 4 respectively. Once we know that this is a complete quadratic trinomial, then we can no longer use the method of extracting square roots, nor the common monomial factoring we did in the previous videos, because those two were useful if our quadratic equation is incomplete, like for extracting square roots when b is not around, and for common monomial factoring is when c is not around. There's also a quadratic formula that we could use in solving for the roots of this given equation, but let us try to practice using the other methods for this. There are 2 methods to be used for a complete quadratic trinomial, one of which is still a factoring, but it's no longer a common monomial factoring. It's a factoring that that is actually possible if our given trinomial is factorable. If the given trinomial is not factorable, we're going to proceed with completing the square method. So let's try to check whether this trinomial is factorable or not. And hopefully we could lead to our result with the same answers as earlier. Let us try to use the AC way or AC method. AC means you need to multiply the A and C coefficients. So they are 1 and 4 respectively. So we have here result of 4. This result for AC is now used, and we are now going to look for a pair of factor that when multiplied will get 4, but when added will result to -4. We know that the factors for 4 is 1 and 4. We could also have 2 and 2. We could also have negatives, -1, -4, and we also have -2 and -2. These 4 pairs of factors, when multiplied to their corresponding pair, will result to the result of AC, which is 4. But which of these pairs, when added, will result to our B coefficient of our quadratic trinomial, which is -4? You only have one, and that is here. We have -2 and -2, because -2 times -2, +4, that's your AC. -2 plus -2, that's -4, that's your B. And once that we have acknowledged this, we are now sure that this trinomial is factorable, and hence we can use factoring here. So we will be factoring this. when we factor a quadratic trinomial, we have two pairs of two binomial expressions of x, because x times x, that will result to x squared, so they must be the first terms. And let's pair them with the coefficients used to solve for AC, and when added will result to b. So this is minus 2 and this is minus 2. Notice here that the two factors are of the same quantity. This is an implication that our quadratic trinomial is a perfect square trinomial, and with that, whenever we have a perfect square trinomial, we only have one specific root. So let's move further. Of course, we're looking for roots. Let's equate this to 0. Once we equate that to 0, we can use here the zero factor property or the zero product property, which tells us that the entire expression, the product of these two factors, will be equal to 0 if one factor or both of them are equal to 0. Of course, you could say that when two numbers are multiplied, they will get 0, so it could be one of the two numbers is 0 or both of them are 0. So with this, our first root is positive 2. Our second root is also positive 2. See, our answer earlier for our root is we only have 1, and that's 2. But there is a multiplicity of 2, okay, for 2. But this will actually be enough for our root of the quadratic trinomial equation here given. The other method is by considering the concept of same binomial expressions multiplied. So you could have this expression here, the square of x minus 2 equal to 0. And you can use here the method of extracting square roots. If you can still remember, extracting square roots was used in the situation where there is no b coefficient. Okay? But we could also use it here. So we will take the root here, take the root here. We have x minus 2 equal to, of course, square root of 0 is 0. And we expect to have plus minus, but 0 is a non-negative, non-positive integer, so it stays as it is. And finally, we'll have the same root of 2. See? Factoring, extracting square roots are both possible to reach the result of 2, but this is only possible because our given quadratic trinomial is proven to be a perfect square trinomial. So again, the point here is, since this is factorable using the AC way and the understanding of it, we can use factoring to solve for the root. Or we can solve this as well. So this is the discussion for this QuadQuiz. Subscribe now.